We're going to continue naming, but we're going to switch types of molecules. Okay, so up until this point, what type of naming were we doing? Or with what types of molecules? Do you know?
Binary.
Okay, binary. That means two. Yeah. But a little bit more broad than that. Starts with an I.
Ionic.
Ionic naming. Good. And when we deal with ionic compounds, that means it's between what two types of things? A positive and a negative, or a cation and an anion, or a metal and a nonmetal. Good, right? So it's always one from the left side of the periodic table, one from the right side of the periodic table. That's what we've done so far. So now we're going to switch gears a little bit, and we're going to deal with naming what we call covalent compounds. Okay, and covalent compounds, your book sometimes calls them molecular compounds, but I'll always call them covalent. Covalent compounds are compounds that are between two nonmetals. Okay, so if they're between two nonmetals, what's that mean both their charges have to be? Nonmetals? Negative, right? That means they both have negative charges. So can we ever have a balanced formula if they're both negative charges? No. So the good thing about covalent compounds is that they do not need to be balanced. Okay, so in that aspect, I think it's much easier to name covalent compounds because we don't have to worry about balancing the charges. Okay? So covalent compounds always come from two nonmetals. So the nonmetals are a small part of the periodic table found on the right-hand side. So it kind of narrows down our compounds just a little bit. Okay, there's a lot less options. Okay? In general, covalent compounds and covalent bonds have to deal with sharing of electrons, and we're going to deal with that in Chapter 6, which will be after this. But in general, covalent compounds share their electrons, and so they're able to bond okay with two nonmetals. Okay? So if I give you a compound, let's just look at these two compounds. Which of those is ionic and which of those is covalent? Okay, first of all, tell me which is the ionic molecule. Okay, the first one says CO2, the second one is CaO. Which of those is the ionic molecule, the first or the second?
Second.
The second. This is an ionic molecule. Why is it considered ionic?
Balance.
Well, okay, not necessarily, but maybe. What's it contain?
A metal and a nonmetal.
A metal. Where's calcium located at?
Left side.
Left side of the periodic table. So if it contains a metal, it has to be an ionic compound, right? I balanced the formula for you, CaO, right? It's a positive 2 and a negative 2. But because it contains a metal, this is an ionic compound. This, carbon and oxygen, are both found on what side of the periodic table? The right? They're both nonmetals. They both have negative charges. So this would be an example of a covalent compound. Okay, so you have to be able to look at these compounds and determine, is it ionic or covalent? Because that changes the way that you name them. Does that make sense? Okay, so you not only have to know how to name each type, you have to be able to identify the difference between the two and then apply the correct name to it. Okay? Okay, so let's look here. I want you to take out your book. Hopefully everyone has, or at least your partner has your book with them. Okay, and I want you to look on page 228 in your textbook. In covalent naming, I'm going to give you a couple examples, and we're going to see if we can kind of pick up on the rules of covalent naming, and then I'll give you kind of the defined set of rules and how we go about covalent naming. But I'm going to give you a couple examples. Does anyone know or can think of any covalent compounds off the top of their head? All right, what about the one that I just gave you, CO2? What's that called?
Carbon dioxide.
Carbon dioxide. Okay, any other ones? Yeah?
Carbon monoxide.
Carbon monoxide. Do we see a pattern here? What's the formula for carbon monoxide? It's just CO. CO. Okay, do we see the pattern? Right? Here's the first, here's the second, and it has a prefix here. Okay, so I'm going to give you kind of the defined set of rules that go into it, but that's it, right? Naming covalent compounds is as simple as seeing how many of each atom are found in that compound, and then writing it out. That's it, okay? So if I would give you nitrogen, oops, I can't spell. If I gave you nitrogen trioxide, what do you think the formula might be?
NO3.
Take a guess, right? NO3, right? Based on the patterns we just saw, that's a pretty good guess for that, right? All right, question so far? Okay, I'm going to give you the defined set of rules because it's a little more complex than that, but in general, that's pretty much how it goes, okay? So, here's our rules for naming covalent compounds, okay? So these are rules for naming covalents. I'm going to lay them all out there, and then we'll try lots of practice ones. Okay, rule number 1. The element furthest left on the periodic table goes first. Okay, so that means if I wanted to form a covalent compound between chlorine and phosphorus, which of those would go first in my order, in my name? Which would go first?
Phosphorus.
Phosphorus would go first. It's furthest to the left on the periodic table. Okay, just like it worked with ionic compounds, right? With ionic compounds, our metal always came first, or our cation always came first, right? We always work left to right. So it's the same thing with covalent compounds. Furthest to the left goes first. Rule number 2 tells us the first element only gets a prefix if there is more than one. Okay, so that's saying if we looked again at carbon monoxide or carbon dioxide, right, CO2, we don't call this monocarbon dioxide, right? The first element only gets a prefix if there's more than one. Okay, so if I change my molecule to C2O2, can we take a guess about what that might look like?
Dicarbon dioxide.
That's right, dicarbon dioxide. Okay, so in this case, since there was more than one of my first element, it gets a prefix. If there's only one, it gets left off. Okay, and that's for the first element. Okay, rule number 3. The second element always gets a prefix. Always, always, always. Okay, and so the standard for this is that it would look like this. We'd have a prefix, and then the root of the element, and then it always ends with IDE. Okay, so when we looked at dioxide, right? We put it together in one word, but that's the formula, right? We have the prefix, and then the root of the word, and always going to end in IDE, right? On your periodic table of ions, all of these end in IDE anyway. But when they're the first element, they keep their regular ending. Okay, so we didn't have carbide dioxide, we had carbon dioxide. Yeah, Hannah.
I was just going to ask, like, what if it's something that goes before carbon? Carbon's the second.
Then it would be carbide. That's right. Good question. Okay. So second element always gets a prefix and always ends in IDE. First element only gets a prefix if there's more than one, and you can make a little side note here. It keeps its regular ending. Okay, so you would need maybe a regular periodic table for that, right? Nitrogen trioxide, right? Nitrogen kept its real name. It wasn't nitride. Trioxide. Okay, so that's just something to think about. Because on here, you just see the ion version of all of those. Okay? Question so far? Yeah, Evan.
What if two elements are on the same distance?
Mm-hmm. So then it would be, usually the bottom one would get to go first, if they were in the same group. Good question. All right, number 4. Rule number 4. And last one. Okay, and this is kind of a picky thing, and this is more of a pronunciation rule. Okay, so when your element starts with a vowel, drop the O or the A from the prefix. Okay, this is a pronunciation and writing type rule, but it's just something to think about, okay? So for example, if we had monoxide, right, we don't call it monoxide, we call it monoxide, right? We drop this O and we put it together into one word. Okay, so whenever I write these with prefix then hyphen word, that's not really how it's written. I'm showing you that to give you a clear picture about the prefix and the word, but we should have that written as one word all the time. Okay, so if I had O5, what would that be called?
Oxide.
Okay, but does my element start with a vowel? Yes, so I drop my A. So this would be pentoxide. Okay? If tri always gets to keep that, di always gets to keep its I, right? So if you would have something that looks like this, I3, what would you call it? Triiodide. Right, that's funky. That's how it goes. Okay, the I gets to stay, but the A or the O gets dropped if we have a vowel start. Okay? Questions? You ready to try some? Okay, let's try some. We'll start with the compounds and then we'll go from words to compounds. So our first element is sulfur. It does not need a prefix because there's only one of them. Okay, our second element is oxygen or oxide, right? And how many of them are there? 3, so it would be trioxide. Okay, we don't drop that I, right? It's not troxide. It's trioxide. Okay, so that's our final answer right there. Sulfur trioxide. You don't have to balance charges. Right? You don't have parentheses, you don't have anything crazy, right? It's just telling how many of each atom are in that element. Okay, or in that compound, sorry, not element. Okay? Okay, ICl4. So in this case, Evan, like you asked, iodide and chloride, or iodine and chlorine, they're in the same row. So usually the least electronegative goes first. So the farthest from fluorine, so the farthest one down. Okay? Okay, did we have iodine, tetrachloride? Yeah, is that what we had? Iodine, tetrachloride. So we're used to thinking quad is 4, right? In chemistry or in science, tetra is 4. We'll see it a couple different times that tetra is 4. So try to hopefully you're not thinking quad too much, but iodine tetrachloride. Any questions? Okay. What if I have all right, Jacob, why don't you tell me what you got?
Triphosphorus diaminide.
Just like that?
Yeah.
How many of you had that same answer? Perfect. Okay, so let's say I gave you carbon tetriodide. I'm going to give you 3 of them up here. CI4. Raise your hand if you agree. Perfect. Okay. Isabel, why don't you tell me what you got for the second one? Into O3. Got it? Perfect. Good. And last one. McKenna, why don't you tell me what you got? SIBR6. Perfect. Perfect. Okay.